Hello and welcome back to another episode of Math with Son. Today we're going to be tackling isosceles and equilateral triangles. Let's get into it. So, if it is an isosceles triangle, that would mean that two sides are equal versus equilateral, all three are equal. All right? So here on number one, we have two angles that are marked equal. If it is two angles that are marked equal, then there are also going to be two sides that are marked equal, and they're going to be the sides that are across, kind of crisscrossy from those angles. So this angle and those angle will relate to these two sides, so that means that this side right here is also going to be 7. All right? And it's the one side that's in between the two angles that is not equal to the rest for isosceles. So this is an isosceles example. For here, we have two angles that are marked equal, which means that this x must be equal to 6 as well. Not only that, but there's another way that you could think about it too. This is a variation of this. This is called a angle bisector type of deal with an isosceles triangle. If these two angles are cut in half, these two sides are equal. See how they're marked? Which means this angle here must equal that angle there. And if we split this angle in between, that must mean that this will also split this side up in half. It's kind of a neat feature. So number 4, we have these two sides equal, these angles are equal, which means this is also having to equal that angle right there. Not angle, side right there. Another isosceles triangle with number 5. This one is more of my favorite thing to deal with. I'm going to start with number 6 though. See how these two sides are equal? If this is 75, this must also be 75 degrees right there for x. Which leads me into number 5. These two sides are equal, which means both of these must be equal to each other as well. So there are two ways to deal with it. I recommend doing what I'm going to do first, and then I'll show you the trick. That means that if this is x, that is also x. So that means that you have x plus 40 is equal to 180 because all triangles add up angle-wise, not sides, to equal 180. Combine like terms, you get 2x plus 40 is equal to 180. Subtract the 40 over, you get 2x is equal to 140. And divide, you get x is equal to 70. Okay, so that's like the slower way to do it. The quicker way to do it is realizing that if these two angles are equal, and we've already used up 40 here, that means between both of these they have to be 140. And then if you cut it in half, you get 70 for each. So that's essentially what we did equation-wise, but you kind of do it almost mentally. All right, next one over here. We got these two sides are equal, which means this angle here and that angle there would be equal. Remember, it's the cross from it. So if we go across from the 54, the side across from it visually would be this one. So that means that this 54 and this angle over here will also be equal to 54 because it is across from this side. So between both of these, we have 54, not 54, 54 plus x equals 180. So we have 108 plus x is equal to 180. We subtract the 108, we get 72 must be equal to x. All right. Similar thing here is going to happen on number 8 because we have these two sides are equal. That must mean that this angle here and that angle here, which is across from it, must be equal to each other, which means that's 75. Well, how much do we have between 75 and 75? Between 75 and 75, we have 150. So we have 150 with that, and then we have an x, so how much more do we need to get to 180? 30, which is what happens when you subtract the 150 from the 180. All right, a unique problem here. We got 65 on this side, which means we got 65 on that side. And if we have 65 and 65 here, together, those make 130. And if that's 130, this would have to be 50 to add to 180. And if that's 50, you got a vertical angle, so this is 50. And if these two sides are equal, then this 50 must equal this 50 over here. And if both of these are 50, how much would be equal to x? Well, you got 50 plus x is equal to 180, Well, you could also think of this as 100 combined, so how much more would be needed to equal to 180? You could subtract the 100, or you could think and be like, well, that means that x has to just equal 80 for this to total to 180. All right, next one. We got these two are equal, and we got these two are equal. I'm going to take the 28, and I'm going to take the 28 away from 90 because this whole angle right here is 90. So if we do that, you do 90, take away 28, you end up with 62. So this is 62 right here. And if this is 62 for this part, then this part would also have to equal 62 because these two sides are equal. And if these two are 62, then you'd have 62 plus the x is equal to 180 because the whole triangle has to add to 180. So that makes 124 plus x is equal to 180. Subtract the 124 over and you get x is equal to 56 degrees. All right, let's throw in some little bit harder angles and stuff. Maybe not angles, a little bit harder variables that you'd have to solve for. So here, if these two angles are equal, and these two angles are equal, and this is a shared side, that means that these triangles are identical, and that means that this 8 will equal a negative 1 plus x, which means x would equal 9 when you add it together. What about on number 14 where we have these two? What do you think they're going to be? Are they going to be equal to each other? You'd be right. So let's just save time and put an equal sign in between them. I'm going to add 12 to this side over here to get that to go away. We're going to get 24 is equal to 2x, which means x is equal to 12. And I said I would skip these, but these look pretty interesting here. Let's just start on 12 and see if we want to go back to 11 as well. We got these two sides are equal right here, which means that these angles are going to be equal where I put dots on. We got this 120, which means this has got to be 60 because it's got to make a straight line. 60 and 120 make 180. And if this is 60 and these two are equal to each other, this is our first equilateral triangle because if you have an isosceles here, which we first thought, if we do 180 minus 60 and then divide by 2, you get 60 for the other two angles. So all three of these are 60, and that means that this is 60, and this is another isosceles triangle which happens to upgrade to a equilateral with all three being 60, which means x is 60 as well. A lot of 60s there. A little frustrating there. So I don't feel like doing 11 after that. That made me upset. But it was our only equilateral triangle. All right, measure of angle 2 is equal to x plus 94, so this is x plus 94. We got 47 here. These are the two angles that are equal, so this is also 47, which makes this 47 from the vertical angle, which makes this 47 from the isosceles triangle, which means that you would have x plus 94 with the 47, adding to equal 180. Combine like terms, you get 2x plus a whole bunch. 94 plus 47 plus 47 ends up being 94 plus 94, which is, I don't know, 47 plus 94 is 188 is equal to 180. Subtract the 188 over, you get 2x is equal to negative 8, which means x equals negative 4. Moving right along. Measure of angle 2. This angle right here is 4x minus 2. And we have, this is 68, so this must be 68. And if these are 68, we can find this angle up top right here because we have an isosceles triangle. And all triangles, this particular one, would have to add to 180. So we have, I'm just going to call it dot, plus 68 is equal to 180. Well, what's 180 minus both of those 68s? You get 44. So that means that this part up here must equal 44 degrees. Well, look at that right here. It's a right angle. So between these two things, they must add to 90. Well, if it's 44 on this side and we have a 90-degree total, that must mean that angle 2, if you do 90 minus 44, is equal to 46. So angle 2 must equal 46. So if angle 2 equals 46, and angle 2 is equal to 4x minus 2, you can set it equal to 4x minus 2. We're going to add the 2 over. 48 would equal 4x. And divide. And you get x is equal to 12. All right. I'm going to stop there. That's going to do it for this one. Until next time, everybody, stay positive, and I will see y'all later. Bye.